Welcome again. Here we see on energy quantization. We're looking at what electron volts, kinetic energy, and photoelectric effects. Electron volts, kinetic energy, and photoelectric effect. In our previous class, I explained to you, I told you that energy of an electron is measured in what? Joules. And electron what? Volts. Measured in joules and what? Electron volts. An electron volts, this electron volts is the energy required by an electron in falling freely through a what? Potential difference of 1 volt. Energy required. Energy required by what? Required by an electron. By an electron in falling freely through a potential difference of what? 1 volt. You have your bulb at home. You know of bulb, put on electric bulb. Inside those bulb, you have what? Gases. There are gases in it. So by the time you switch on, you put on the switch, that you are closing the circuit. When you close the circuit, those gases acquire energy. And as they acquire energy, they get what? They get excited. They jump from one energy level to what? Another. So the energy required by an electron, by this what? An electron, in falling freely through a potential difference of 1 volt is known as what? 1 electron volt. And this electron volt, 1 EV, is equivalent to what? 1.6 times 10 raised by what? Minus 19 what? Joules. Joules. So, since before you put on the switch or you close the circuit, the gases are at rest. They are all in ground state. They are what? They are all in what? Ground state. And by the time you put on the switch by closing the circuit, the potential energy those gases has at that point, as they get excited, the potential move toward kinetic energy. So electron volt is same as what? Because it's as 1/2 what? The mass of the electron multiplied by what? The square of what? Velocity. So this is same as what? Kinetic what? Energy. Kinetic what? Energy. Now, moving forward from here, having known this, moving forward from here, if you have an issue, you can rewatch the video. Moving forward from here, let's assume now we've discussed about lights. Let's go to something different. I'll use something different to explain this scenario. You have a ball. You have a ball here, and this is a person, someone standing with a stone. This ball here, let's assume it's a ball. He's standing here with a stone, aiming at this ball. When he now threw the stone at this ball, what do you observe? Let's assume when he threw the stone glued itself to this ball. The ball moves. Let's assume the ball moves to this direction. Or, okay, the ball moves to this direction. And stops. Discover that the energy he applied to the stone does not just displace this ball. It does not just displace this ball, but it gave this ball what? It changed the energy of this ball from potential to what? Kinetic, making it to what? Move. So let's assume that this energy he used to hit this ball is E. And recall in our previous class that we said that what energy is what Planck constant times what frequency. This energy is equal to what the energy just to displace this ball. Just to displace this ball is what work function. Is what work function. Take note. I will go through it gradually. I'll take my time to explain it so that we all will be on the same page. The energy he used, I will still go back to what the using of electron. I just want to understand, have an idea. The energy to displace this, but let's call it what work function. Then plus the kinetic energy, because are you getting me? And this work function, because the energy here does displaces the ball and make the ball to move. So this total energy did these two things. So that is the energy equals to these two things. And this energy is same as what? Planck constant times what? Frequency. You all know that before now, by now. And this work function is same as what? Planck constant times what? Threshold what? Frequency. And our kinetic energy, this kinetic energy, 1 over 2 mv squared, mass of the electron. I hope you are with me. So if I want to make this the subject of the formula, I have my kinetic energy. Kinetic energy equals to Hf minus. Do you understand? So a kinetic energy, I've told you, is same as what? Kinetic energy is same as what? Electron volts. So this is equals to what? Electron volts. So when light, when heat hit a metallic surface, the energy is able of that light is able to what? Knock out electron. And not just knocking out electron, you're able to give the electron that's being knocked out what? Kinetic energy to fly out. That is just what it means here. Just assume you hit a ball. The total energy you use to hit that ball is equal to the energy that displays that ball plus the kinetic energy the ball used to move the distance it moved. So this is what happens every day when you kick a ball. This is what happens every day when you throw a thing. Even this is what happens when you slap a person. The energy applied equals to the energy enabled to move the face, displace the face, and make the face turn to some points. I use this example so that you, as a student, will what? Bring it home. Understand it that this is just what happened every day of our life. Our total energy equal to the work function to displace the ball plus the kinetic energy that that ball would acquire. And this talking about, because this is just for you to understand what we are talking about, they're bringing it towards radiation. This total energy is what? Planck constant times frequency. And this work function, energy required just to what? Displace the ball. Just required to displace the electron. Now remove the ball, put in electron in there. That's our work what? Function. But this is our kinetic energy, which you already know before now. So making this guy, which is same as what? Kinetic energy. Let's use EK. Wow. Kinetic energy. Let me use EK to represent it. To represent it. Okay. Bringing it here also. for bringing it here. It's same as this. And with this, I think we can, it's just simple, just simple, just simple, just simple, just simple, just simple. With this, I think we are ready to dive into what? Some questions and see how some questions have been what tackled. I believe by the time we solve like 10 questions, you understand how this really works.